Okay. I see. Okay, so we can ask our assistant Sebastian. This is exactly what he also works on, and you can ask him any questions about supermassive black hole jets, blazars, and quasars. Cool. Yeah, let me bring you the mic, just because this is actually being recorded. You want to come up? Hey, Sebastian, if I give you a mic, could you talk to us about blazars and quasars for a couple minutes?
I could, but I just came in, so I don't know what you've already heard.
Just some visualizations of it. It wasn't anything. We could hear it again anyway, because believe it or not, when you hear about supermassive black hole jets the first time, you don't take it all in. Anyway. Let me turn up the light.
So you know how there's like black holes and how they take in energy and suck it all in? Is there like something opposite of that, like a white hole that instead releases energy?
Well, the interesting thing about those objects is, in principle, we have both. So we have this really heavy. Is it fine if I talk without mic?
No, because everything's being recorded.
It's recorded. Okay, I will take the mic.
Yeah.
That's fine. So the interesting thing. Then I will also repeat the question. If we have the supermassive black hole which sucks in material and energy, if there's something that does the opposite, and in those objects, in principle, or we actually have both. So we have this very heavy, massive black hole which is sucking up material that's in the disk around the black hole. But those systems consisting of both the black hole as well as the accretion disk around it emits a lot of energy because this disk is heating up and the disk itself radiates a huge amount of energy. So we see light from this very heated up disk which can outshine the entire galaxy. So you have billions of stars in the galaxy and you don't really see the galaxy if it's really far away. But you see this very tiny region in the center, which is much more luminous than the entire galaxy around it. And then some of those objects form the jet, as you've seen in the video. And those jets are also outflow of material, and the jets itself radiate light. And those are also extremely energetic. So those systems do both. The black hole itself sucks up material, but as part of this whole system, there's a huge outflow of energy and particles.
Other questions?
As a researcher, how are you able to analyze all this information, especially with the energy being so powerful? Like, what is a process, or what do you guys do? Because as black holes is like, so you don't know what happens to it or anything.
Yep, that's right. There are lots of open questions, which is why people like me study this stuff. But well, especially with blazars, for me personally, the very fascinating thing is those jets emit radiation throughout the entire spectrum, which means we use telescopes which observe at radio frequencies. We go to millimeter and microwave radiation. We use optical telescopes. We use X-ray telescopes in space and gamma-ray telescopes in space. So we try to cover the entire spectrum, and through that gather a lot of information. Those objects are extremely variable, which means it's useful not to look one time, but keep looking all the time, because they vary on different timescales. You see variability over years in radio frequencies. At gamma rays, you can see variation on minute timescale. So what we try to do is, over all those different frequencies, using dozens of different telescopes, observe these objects continuously as best as possible and gather as much information as possible to analyze what's happening. And this can tell us something about the processes happening in those objects. And with that, we mainly study the jet itself. But, well, there are questions like, we don't know how is this jet actually formed. why do some of those objects have jets, others don't? And what's the actual connection between the black hole and the jet? There are basically two theories, but we're not sure yet.
So these are basically like black holes with jets. How does the jet form?
That's the question.
That's one of the questions.
Doesn't the black hole stop things from escaping?
So yes, black holes stop stuff from escaping up to a certain boundary. So you have a certain radius in which nothing can escape, and then it depends on how heavy you are. So if you come close enough, there's no way out. But if you're outside of this radius, then you have a chance to escape. And that's the reason why we see light coming from the accretion disk, because that's not sucked in by the black hole. It's far enough, far away enough to escape the black hole. So it depends on how close you get to the black hole, if something gets away or is falling into the black hole.
If I'm a black hole, you can't escape me. I could try to like accrete all you guys, and I'm trying to get you, but I'm very massive, so you're gonna like maybe circle around me, and then you might run into each other, and if you run into each other, you might scream, and then we hear your screams. I don't know.
I was wondering, because in the video it said that the jets are pointed towards Earth. Is there a specific reason or like a relation, or is it just by chance that the jets are pointed towards Earth?
So it's by chance if a jet is pointing towards us or not. So we see jets which are not pointing towards us. The thing is, this is Einstein's special relativity. If you have a jet pointing towards us, it's moving extremely fast. It's moving close to the speed of light. And then if you use this theory of special relativity, it tells you that radiation that is emitted in the jet is actually boosted. So in principle, the idea is if I'm a particle in this jet, I radiate in all different directions. But since I'm moving in this direction towards you, even radiation that I emit in this direction will come to you. So it's not just the radiation that this particle emits in this direction, but basically over half a sphere or even more, all this radiation is pushed towards the observer, which means those really fast jets which are pointed towards us appear to be much brighter. So objects that are very far away, we're really able to see them because of this effect. So we're more likely to see those jets which are pointing towards us at far distances than those which are not pointing towards us. So the ones which we see from the side, those are ones which are closer by. So in principle, they can be all around us in all directions. It would be strange if they all were looking towards us. Then there would be something particularly special about us, which is...
Someone is trying to tell us something.
probably not the case.
Okay, we'll take one more question, and then we'll move on. But if there's one from a new person. Yep.
What are these things? I'm not sure I missed it from the video, but what are these things made out of? And if they're pointing to Earth, couldn't that be a bad thing? Makes me a bit nervous.
So there's no reason to be nervous.
Unless you're an astronaut.
If okay, that's, well, I don't want to go out there. You do. But that's your decision. So jets are made of particles. So which particles in particular is one of the open questions. So we want to find out, is it just electrons or electrons and positrons? Are there heavier particles? So are there protons? Those are very detailed questions we try to answer. But the main ingredient is we have particles and lots of radiation. And that's what we see from the jets.
And if I understand this right, which I'm not an expert on this, I think why we have to worry less about it on Earth, as we learned in the Sun chapter, first, the magnetic field deflects a lot of things, and secondly, for some types of radiation, the atmosphere is filtering it out. But I think it's for the electrons, they're ionized, so they're going to be deflected by our magnetic field. But if you're in space and you're hit by a galactic cosmic ray, like, this isn't necessarily a good thing. Is that right?
Yeah, and those objects are so far away that
there's not that much.
It's not that much.
It's not that likely.
So
it's unlike the sun. If
yeah.
the sun has a solar flare and you're in space and it's a big one, or a coronal mass injection, then you're really in trouble. So. Okay. Yeah. Yes, one last one, Crystal.
Is it possible for the jet to be pointed toward the sun? And like, if it is, like, can it over the radiation the jet emits, can it overpower the sun or something?
So it can point towards the sun. I mean, in principle, from the point of view of the jet, it's so far out, it doesn't really make a difference if it's Earth or the sun. That's no difference from the spot of where this thing is actually sitting in space. So the thing about radiation that we observe is the further those objects are away, the less luminous they appear, because the radiation is spread out over a large volume, and the further away, the larger gets the volume. So in principle, those things are much more luminous than the sun. They don't appear as luminous because they're extremely far away. Probably not in the sense that you mean. The universe is expanding, so in that sense, they move away from us, but they're not traveling around. It depends how you see it. I mean, you have galaxies and galaxies are in clusters, so everything is moving around everything. So in principle, yes, but they're not coming close to us, and they won't be in the neighborhood and destroy our sun. That doesn't happen.
Yeah, I think the only case where if we had a star that was super near us and that star exploded, that star might get very bright. And I don't think it would be the case that we have a star that's close enough that would explode and be brighter than the sun even for an instant. But mostly things are so far away that no matter what they do, it's never going to be as bright as our nearby sun. Okay, let's do some live coding. Thank you all for the questions, and thanks, Sebastian, for the impromptu speech. I think black holes are a fascinating topic. There's a lot of good things online. Okay. Sorry to put you on the spot. Thank you, Sebastian. Okay, let's see how we're doing here. Yeah, I will change it. I'm not done yet, but that is a good point. I'm not going to, I'll just do some live coding to start out with, but I will hook up a keyboard. Do you guys have any live coding requests for my section? I'm your coding DJ. Do you guys want to see more stuff on Git? Do you want to see more stuff on classes, on tests and exceptions? What's up? Okay. Sounds good. So let's make, let me think of a good class example. So let's make an asteroid class. Does that sound good? Okay. And I might make some mistakes here. So let's do it. So what should I call my class asteroid? That's a good name for it. Asteroid. Sounds good to me. I bet Python doesn't have a class asteroid. So how do I define a new class? What's the first thing that I write if I define a new class? Class. All right. And then what do I write next if we're going to create a class called asteroid? Asteroid. Asteroid. Cool. And then what do I write next? Colon. Okay. It's optional, so you can have parentheses, and then you can say it's of type object, and you can put another type there. This is done by default, so you don't need it. Later, when we have inheritance, so we're going to make a specific type of asteroid, and I'm going to ask you guys for advice there because I didn't go to Carrie's lecture about different types of asteroids. So we'll make a class that inherits from asteroid, and that's when we'll put something like asteroid. Asteroid. Yeah, that will work. All right. So my class asteroid is going to have I'm going to have an initialization method, and I'm going to give my asteroid a mass, and let's pretend asteroids are spherical. So I'll give it a mass and a radius, the radius of the sphere. It's an approximation. So for my initialization routine, for my initialization method, how do I define that? What do I start with if I define any new method or function? Def. Okay. And then the initialization method has a special name in Python. What is it? Init. Yeah. Yeah. Underscore init. And then what do I have next? Self. Anything else? So we do need parentheses here, but self doesn't go by the class definition. Self goes by every class method. The first parameter is always self. And when you call it with arguments, that's the parameter that you leave out. And so that's the kind of confusing thing about class methods versus your typical functions. That's basically the only difference. Other than that, they're functions inside the class asteroid. But because they have the self, they're going to be associated with and because they're defined within the class, they're associated with a class asteroid. Then your dots, whenever you go and use the class method, the dots will automatically fill in self, will be the instance of the class. So we have the self, and then we wanted also a mass and a radius. So where do I put the mass and the radius? Mass, comma, radius. Okay. And now what do I put in here so that we save the mass and the radius? Pardon? Self dot mass equals mass. There we go. And what next? Self dot radius equals radius. Okay. So now I'm going to make one more class method called hit Earth. That takes, it doesn't need any parameters. That's just what it's going to do. So how do I define that? Def, and then hit Earth, and then what's always my first parameter of a class method? Okay, good. And I don't want any other parameters. But I will do self.explode equals true. And that'll be it. Okay. I don't claim that this is the physically realistic model. When you do your asteroid projects, maybe do something else. Okay. Now, I don't actually know the answer to this, so I'm hoping you guys can teach me something. Were you listening to Dr. Nugent, Carrie's, one of our assistants? She gave a talk on asteroids, and she mentioned there are like different kinds of asteroids. Could you tell me a certain kind of asteroid? I don't even know.
There's the asteroids orbiting around the Earth. Not the Earth, but our closest.
That are close to the Earth, the near-Earth asteroids. Yeah. What are other types of asteroids? The farther ones, sure. Okay. So let's make a first, before we do anything, the next thing we're going to do is make a new class that inherits from that. But let's make an instance of our asteroid class, and I'm going to call the asteroid Bob, because it sounds like a good name. So how do I make an instance of the asteroid class? A new instance. Okay, so the variable. Okay, so the variable Bob. Okay, Bab. Bob equals. And then what do I write next? With a capital A. And then what do I have next? Parentheses. And then what do I need to put in the parentheses? Mass. So what would be a good mass? I don't know. Let me make it really big. Okay.
5,000 units.
Yes, exactly. And then we'll make the radius 2,000. Okay. All right. So if I want to print the radius of Bob, how do I do that? I'm going to do print Bob.radius. So that's a good idea to do the self. We can only use self within the class definition. So the only time you use self is if you're within a code block that you have a class something on top. Then you can use self. If you ever use self outside of that code block, it's going to crash. You're not going to need it. So that's how you remember. If you're inside a class definition, which we know because we have class something or other, colon, then you can use self. Self is always going to be, for class methods, it's going to be the first parameter. Then after that, if you want to set anything related to a particular instance, you do the self dot notation. Because if you don't do the self dot, what's going to happen if I set exploded equals true? What do we? It'll just it'll forget about exploded afterwards. If you remember, if we define something in a function, which first I'll print Bob's radius. So if I do def new function x equals 5, new function x, it doesn't know what x is. It forgets it afterwards. So what that self does, Crystal, what that self does, it means not to forget it within the class. Save it within the class instance. Don't forget it after the method. You can also use variables within methods, just like we do here without the self. We can set it equal to 5. We can multiply it by something. It's just if you don't do the self dot within the class definition, it's not going to save it for later. So if you want it to be saved, then we got to do that self dot. So if I wanted Bob's mass, what do I instead have to type here? Mass. Okay. Okay, if I wanted to call Bob's hit Earth method, how am I going to do that? Okay, and then what else? Parentheses. You guys are great. Tons of improvement. This is awesome. All right. So now if I do print Bob dot exploded. That should hopefully be true. Cool.
I just think Bob's math, but I think Bob is a bomb.
Yeah, maybe Bob should be a bomb. Who knows? Okay, now. All right. Now I'm going to make another one called Janel. I just made that name up. So I'm going to make a new asteroid, and I'm going to give it a small mass and a small radius. What happens if I do Janel dot exploded? Print. You think error? That's right. The reason why was the method that defined exploded was hit Earth, and I haven't called that method yet, so it's not defined yet. So that self actually goes ahead and defines it for you. So that's why most of the time when you're defining things related to a class that you need and expect, you do it within that init. What's up?
I remember for chapter 2, or it was the one for classes, we're dealing with, so basically we had to create a function, and then when I tried to create the function, I used self dot blah blah, but what was the problem with it is that I was supposed to use Bob dot self dot whatever.
Yeah.
So my question is, when do we use the Bob, and when do we not use it?
Sure.
Like,
So
after we initialize it,
that's
we
right.
have to use it.
So after, you can only use self within the class definition. And then whatever you're doing related to the class, you should be doing self dot that. So if I wanted to, what I could do, let's change our asteroid definition. Hopefully it'll let me do this without too much annoyance. So I'm gonna change my asteroid definition here to set, hopefully it'll let me do this. No. Okay. Class asteroid def init self mass radius self.mass equals mass self.radius equals radius. Now I'm going to define self.exploded equals false in the init function. I can, yeah, we did that before. So I'm going to do def hit earth self.exploded equals true. Now I'm going to do def unhit earth. I don't think that that's possible. Self.exploded equals false.
Okay, never mind, Bob.
Okay, so finally I'm going to do def randomly hit earth. Self. Okay. And instead of randomly hitting Earth, I'm going to call the hit Earth function. So here, here's where I'm going to use the self, Nayeli. I'm going to do self.hit Earth. Okay. So I could also, I didn't feel like doing this, but I could make this a random choice and sometimes hit Earth or unhit Earth or whatever. So now if I do, I'm going to make a new Bob, or I'll make a new Janel. Janel.randomly hit Earth. Hopefully this will work. Janel.exploded should be true. Okay, so this is a long way of going about answering your question. But when you want to call a function within the class definition that's of the class, that's when you use self. Or if you want to save something in the class instance outside of your class method, that's when you use self. You should never, ever, ever be using self outside of a class definition. If you're not inside a class definition and you use self, it won't know what that is. So if I try to use self, I don't think it'll know what it is. It has no idea what it is. So you definitely can't do it there. The only time you can do it is in a class. And I don't think it'll even work without the self, but I have to double check that. So I will try this with just hit Earth, and we'll see if this even works. We're going to make a new channel. We're going to randomly hit Earth, and it doesn't know what it is. Because if you don't have the self, it's just like outside of here. I can ask Janel to randomly hit Earth, but I can't just type randomly hit Earth, because we don't know what that is. It's the class itself. So you really need, if you want to call within a class method another class method, you need that self to say, don't look in Python everywhere, look within this class for that method. So now we'll be able to make a new channel. We'll be able to randomly hit Earth. And channel.exploded will be true. What's up?
I was going to ask you if instead of using self, you use the object name, and I realized that doesn't make that much sense.
Yeah, so I didn't teach you guys about this, but there's a way to have something called a static method. And what that means is that all these methods belong to a particular instance of a class. I have to do Janel equals Asteroid something or other before I can call any methods of the class.
Wait, you can define something for just one object, and then
Yes, I can.
instead of calling self, call it Janel?
Yeah, instead, well, I'm not going to teach you guys this, but I'll just show you the syntax very quickly. You can make, there's a way of making functions that I don't need to make an instant, but I could do asteroid.compute5.2. And here, this would be, if you define the method in the right way, it would be defined only with a dot on this class, but there's no instance of the class. So there's no way to save variables. There's no, with a self, when you create an instance, you can save mass, you can save radius, all that sort of stuff. With a static method, it's just basically a way of saying that only remember this name in conjunction with the asteroid object. It's a bit like the Python modules, where if you, let me finish explaining and then I'll take one question. So with a Python module, you can use plenty of functions in a module, but unless you import it in a particular way, you have to do the module name dot the function. And so there is a way for classes to do something like a mini module, where you define functions that are just defined within that class. And that's a good idea if maybe it's something that that class has to do a lot. So it gets a bit confusing to remember, and most people don't do that very often. So that's why I'm focusing on instances of classes. But that's something that I recommend. If you just go ahead and read a book on Python before you've done any Python programming, it's super boring. If you spend 6 weeks learning Python like you do here, and then you go work and read a book on Python, even if it's a short book, you'll go, oh, I finally understand. I get it. I understand. It'll make sense, and that sort of stuff. So I've tried to give you kind of the bare minimum of what you need to understand, but you also, there's a lot that you'll get to learn too. But we'll focus here on the class variables. So for the purposes of this class, we're only going to do types of methods where before you use them, you have to create a new instance. And then you'll be able to save all sorts of things associated with that instance. And then when you're defining the class, you can use self if you want to call any class methods from within the class. Outside of the class definition, you never use self. Okay, so.
Put, like, for example, inside the definition of asteroid dot hit Earth is the self that hit Earth, and it would do basically nothing because it would be just maybe a dummy instance.
I think if you did asteroid.hit Earth, it would just crash. So I think if we do asteroid.hit Earth, that's just gonna crash. But let's try it within the. Let's try it with. That's what the self does. So the self automatically makes the dot be the instance that you're calling it with. So let's try this within here, asteroid.hit Earth, and I do not think that this will work. Janel, and then I'm going to do janel.randomly randomly hit Earth. And yeah, so that will not work. You really do have to use the self, unless you go ahead and read up on these static methods and how to do that. Let's make, we've made Janel, we've made Bob, we've made a variety of asteroids. Let's make a new class that inherits from the class asteroid that's going to be a near-Earth asteroid. So how do I make a new class that's like that? Class. And then what do we want to call it? Near-Earth asteroid. And then if I want it to inherit from the class asteroid, what do I do next? Asteroid in parentheses. And I'm going to make this exactly like asteroid, except for I will make it, let's give it one more method. Let's give it a sparkle method. So what should I call my sparkle method? Sparkle. A lot of these questions answer themselves. How do I spell sparkle? Sparkle?
You spelled it the right way.
Okay, that's a good idea, Nico. Okay, and then what's my first parameter of any class method? Self. Okay. And then I'm going to do sparkle. I'll do like a number of times we should sparkle. Number of times. Okay. And I'm going to do for I in range number of times, print sparkle. And then I'm going to do self.hit Earth, because I'm mean. Anyway, let's create a new near-Earth asteroid. What should we call it? Sierra, what's a good name for an asteroid? Pardon? Rock. Okay, let's call it Rock. And how do I create a new instance of a near-Earth asteroid? Will?
Type in near-Earth asteroid.
Near-Earth asteroid. And then what next? Pardon? Okay, so you think I should do this? Let's try it. It says init takes exactly three arguments. 2 are given. So that's wrong.
You have to put in its mass and radius.
That's right. Yeah. So it inherits the same init from asteroid because we didn't redefine it, nothing. So just like when we defined asteroid, we gave it a mass and a radius, we also have to give near-Earth asteroid and a mass and a radius. So I'm going to make its mass really small. I'm going to make its radius really small for some arbitrary definition of really small. And Nayeli, to answer your question, sparkle wasn't an init method. So it's not initializing the class. It's something that we can call on an instance of the class. So we can make rock sparkle. And in that case, we do have to enter the number of times. So let's go ahead and make, well, let's do rock dot, let's see if it's exploded. Nope. So let's make rock sparkle. How do we make rock sparkle? Rock dot sparkle. And then what else?
Also put like something inside the parentheses.
What should I put inside the parentheses?
5.
5. Okay. So what's this going to do? It's going to print sparkle 5 times, and then what's it going to do? It's going to explode, hopefully, if I define my code correctly. Sparkle, sparkle, sparkle. Okay, sparkle, sparkle. Okay, so rock.exploded should be what? Cool. And now if I want to get the mass of this rock, how do I do that? Rock.mass. I saw that. And then what about the radius? Now, what if I want to set the radius to something new? Like instead of 1, I want it to be 7.
Rock.radius equals, say, 5,000.
Rock.
Really non-dense rock. Like
Okay.
maybe not easy with the radius. I mean, huge.
Okay. So now if I do rock.radius.
Rock radius.
Okay. Now, what if I want to make up something brand new, like well, let's say I want the rock to have a color, and I want it to be red. Could I do that? How would I do that? Rock.color equals red. So this is something that you can see that once you have an instance of a class, and this is why, so all those other asteroids that we created, like Janel.color, Janel doesn't know anything about color. None of these things know anything about color. On any instance that you have, you can set its instance variables to whatever you want, and that can be useful when you're performing your computations. The thing to be careful there is that we know from the class definition, from the init, that every asteroid is going to have a mass, a radius, and exploded. But not every asteroid is going to have a color. So I could have Bob, Janel, a variety of things, and if those are all in a list, and I do .color for every one of them, some of those are going to crash, and some of those are going to work. So if you use the variables like that, you just have to be careful in your code how you're using it. But that's one of the reasons why there's inheritance, so that we can know that usually asteroids don't have this sparkle method, but if I have an asteroid that happens to be of type near-Earth asteroid, then it might. It does, definitely, in fact. So if I do type rock, what is that going to say? And then I'll answer a question from you, Nico. What is type rock going to give me?
The near-Earth asteroid.
Near-Earth asteroid. Well, it's an instance. Type near-Earth asteroid. The class object. Okay, this is very helpful, type. I thought actually the type would tell you, I was under the impression that the type rock would tell us what type of, would give us our class definition. So I'm doing something wrong with type. Let's see. Type, name, type, rock. No, I don't think so. It does. If I just type rock, then it does say that it's a near-Earth.
What happens if you type rock with parentheses?
Oh, rock. Oh, that wouldn't work because. No, it would not.
Call.
Yeah.
Call method.
Exactly. So a lot of these underscore methods you can overwrite. So for example, if I do print rock, that doesn't really do much for us, right? But what I could do is, and this is again, let's see what time it is, some advanced usage, but with live coding it's good to have some advanced stuff too. So I'm going to do class near-Earth asteroid, 1, 2, 3, 4, def, string. I think this is what I do. I forget the exact method that I have to redefine. And then I'm going to do print self.mass, print self.radius, print coming for Earth. I don't actually know if this will work. I forget the name.
Can you return something?
Pardon? I think now if I make a new rock, let's see, rock, let's make a new rock. Okay. I think if I do print rock now, it might call the string method. Print rock, let's see. No. Oh, I have to return something. That's right. There you go. Very good. Thank you, Nico. So it's not the print that I need. It's that I have to, for return. And then, thank you. And then I'm going to return. Actually, these are going to change. Sorry. Change this. Coming for Earth.
When you return the string, choose the base.
There we go. Let me see. Oh, I see. I'm like kind of. Here we go. This was not. All right. Hopefully that'll work. And then we'll make a new rock, and then we'll see if this print rock will work. Okay. So now I basically redefined print. When print does something, it calls the underscore string method on the object, and we've redefined it.
Wait, does that mean that you can make it so, say you're really evil, you define it so return one thing as a string, one thing as an int, and one thing as a boolean that are completely unrelated?
I think that it requires it to be a string. So I do think that if I return, say, a tuple, it's going to get annoyed. So I do think that the string method has to return a string. So let's make a new rock. That's, well, I'm just double checking. So now that it does have to return a string. But yeah, you could, for example, if you wanted to be very evil, you could redefine that, and it'd be very hard to debug. Because you could try printing something, and then if someone had redefined that, and then always returned 5, then it would be super, super confusing.
No, what I mean is, like, as a string, it imports, this is a string, a very interesting string. If it was int, it would return 5. If it was a double, it would return 57.
Yeah, stuff like that. Yeah, so you can do a variety of strange things with these things. Okay, so I didn't have a chance to torture.
That explains how numpy, I bet there's a multiply method.
There is, yeah.
I'd like to see that. I want to see the source code of numpy now.
Yeah, so, okay, so we have time for, let me see if, did I plug this in? Okay, I do have a keyboard. So we have time for just a little live coding from you guys. Does anyone want to volunteer to learn something for the rest of their lives by coming up here and making a mistake? I see Momo smiling. You wanna? Let's do it. All right. So could you make a class that's the name is your last name?
Okay.
And the init is should take in one.
Totally new class?
Pardon?
Totally new class.
Totally new class, yeah.
Oh, crap. And, sorry.
And then it should have an init method. That's fine, yeah. And then the init method should have the normal parameter plus a first name.
Then I'm pretty sure that's it.
So now you want to set the, just like we did with mass and radius, you want to save the first name in a class variable that's called first name. Okay. So before we go on, you have done a couple things that are a little confusing. So what is first name here? Does Python know what first name is? You're setting it equal, and it always, the thing on the right-hand side of the equal, Python has to know what it is.
Okay.
And Python doesn't know what first name is. So you're going to have to change that to something else.
I just switch it, right?
You could have left the left side as it was. That was fine, because you can do self dot whatever, and then it needs to be something that Python knows what it is.
Moran.
Sure, that sounds good. Now push return.
Okay.
Enter.
Oh.
Okay. So we've seen here, actually we're going to use this just fine. He's called the variable moise, but he could have called it first name, and that would have worked. He could have called it Bob or Tina or whatever. It's a little confusing because we're going to do this for a few members of your family, and Moise isn't always going to be Moise.
Okay.
So it's his first name. It's Momo's first name. But we're going to use this more generally for a few people in your family. So could you create a new instance that's equal to, it's going to be a sibling's name, and initialize it with that sibling's name?
Wait, right.
Try it. Try it.
Oh my god, I'm trying to remember.
So when we created a new rock, look up on the screen, walk over just away from the keyboard. When we created a new rock that was an instance of a near-Earth asteroid, you're going to do something similar, except in your class, instead of a near-Earth asteroid, it's Mukri. So do something that looks kind of like that. And we're not going to give it a mass or a radius, we're rather going to give it a first name. And then it needs one argument that's the first name. And it should be a string. So make a string, that's the first name. Cool. Now push return. All right. Now make another family member.
Okay. Isaac equals. Okay, I see what it did.
Yep. You can just fix that. Okay. Now I want you to print Sarah's name.
Print. Okay.
Nice. Yeah, just, there you go. So do you see why it would have made more sense to call Moise first name now? So Moise was a confusing name because it's not always going to be Moise. So if we had instead called that first name, then when you print Isaac first name or print Sarah first name, then it'll be okay. But you get the basic idea, I think. It is a little confusing, but yeah. Okay. Thank you.